Hello everyone and welcome back to the LeetCode-grind. Today we're continuing our study of binary search with our problem 34, find first and last position of element in sorted array. It says here that we're given an array of integers num sorted in non-decreasing order. So it's increasing with possible duplicates. From here, we are to find the starting and ending position of a given target value. Then, if target is not found in the array, then we just return -1, -1. You must write an algorithm with O of log n runtime complexity, which basically hints at binary search. Okay, so a basic binary search is simple enough. What makes this challenging is that we have to find the first and the last. So to illustrate that point, let's go through an example here. Where we have this number. Okay, and then we can have some indices here. 0, 1, 2, 3, 4, and 5. Okay, and then our typical binary search would be, let's also note down our target. Let's say our target is 8. Let's say for fun that our target is 7. Okay, now we initialize our left and right pointers. Okay, and then the middle is left and right divided in half, so 0 plus 5 in half is 2.5. We'll floor divide it and say that is our midpoint. And check, okay, is the value in the middle, which is 7, does that match what we're seeking, which is target? It does. However, the tricky part is we also need to consider, is it either the first in the array, in which case, sure, you must be the first matching one, or if there is a value to the left of the matching value, is that value on the left less than what we're looking for? As in, are we sure that this is the first matching value by checking that the value on the left must be less than our target? Now, if we were searching for the last element, the way we would flip that logic is say, okay, so we're back in the middle. Is the value in the middle matching? Yes, it is. But is it the last element? So for the last element, we check, is it last in the array? If it's last in the array, well, then it must be the last element. Otherwise, if there is a value to the right, is that value for sure not equal to the value we're looking for? Is that value greater than our current value? Thereby making sure that it is indeed the last element in this sorted array. Okay, and then with that out of the way, let's get our logic going. All right, so we're gonna have some helper function. Let's say we're gonna make it find something. We're gonna say if it's first, then we're returning if it's a first. If that boolean is false, then we're returning if it's the last. Okay, and assuming we have this helper function, let's say we find our first value. And the default is first, so that essentially is basically passing in true. And then if we find the value, or if we don't find the value, that means that target doesn't exist. So if there's no first matching element, there certainly won't be a last matching element. There won't be that element at all. So if first is equal to -1, then we can straight up return -1, -1. Otherwise, we can also find our last matching value by passing in false, first as false, by passing in first as false. Then we return first and last, and that's pretty much it. For the actual find helper logic, we'll use what we used here, which is we initialize the ends. So we have left and right to start as the start of the array and the end of the array. And as long as those two pointers don't cross, calculate the midpoint between the two, which is left and right, integer halved, and say, okay, what's the easiest thing? Well, if the num at our current midpoint, if that number happens to be less than what we're looking for, so it doesn't match, and it's less than what we're looking for, then we can discard everything on the left, including this midpoint, because it doesn't match our target. And we can do that by updating our left bound as n plus 1. Now, if the nums in the middle happens to be larger than the target, then we know that every number in this sorted array, every number from this midpoint to the end is larger than the target. So we can discard the entire right side of this num. And we can do that by updating our right boundary to be n minus 1, because n is already too big and everything after that will only be bigger. Okay, now this is the interesting part, where remember, if first, then we're checking one thing, otherwise we're checking if it's last. What are we checking? We're checking either that m, the middle value, happens to be 0, in which case there's no value to the left, and we know that this is the correct first. Whereas here it would be if m is equal to length of nums minus 1. So is it the first, or is it the last? Or if it's not the first and we're looking for the first one, then is the nums to the left of it less than the nums at mid? And if that's so, we return m. And then if we are looking for the last matching value, instead we're saying, okay, is it the last position? As in, is there no number to the right of us? Or if there is a number to the right of us, is that number larger than our current middle number? And if so, then we found it. Now let's say this returns false. It's not the first, and the previous one is not less than. So we still need to continue our search. Then we can say, okay, no worries, let's update our right bound to be n minus 1. And this is basically a scenario where we end up in 7, but the left guy is not less than us. It's equal to us. So our answer may lie to the left of us. I mean, it most certainly does. So we need to continue our search to the left. And to do that, we discard everything from here forwards by doing right as n minus 1. And here it's the opposite, where we say left is going to be n plus 1 if our search must continue to the right. So if we were looking for an 8 and we landed here, the number to the right is also 8, so we will want to continue our search to the right by discarding this by setting the left pointer beyond the middle pointer. And believe it or not, that's pretty much it. And then of course, remember this must return -1 if we don't find the number. So if we never exit here, then we return a default of -1. Let's give that a go and hit submit. And there you have it. This was, once again, a binary search problem 34. Find first and last position of element in sorted array. We have this helper function. It's long, but the logic is simple enough. It's just many lines. And then once we have this helper function, we just use it and return our result. Thanks so much. Happy coding, and hope to see you next time.